Hello everyone, welcome back to my YouTube channel Pawan's Learn Tech Hub. Well, my name is Pawan Kumariam. Presently, I am pursuing my fourth semester CSC in Sri Venkateswara College of Engineering, Bangalore. I am from the department of CSC, Computer Science and Engineering. Today, we're gonna take a subject on analysis and design of a algorithm, and the topic is insertion sort with algorithms, their steps and efficiency, and topological sorting with two types and graphs. Insertion sort. An insertion sort is a simple sorting algorithm that works by iteratively inserting each element of an unsorted list into its correct position in a sorted position of the list. It is stable sorting algorithm, meaning the elements with equal maintenance, maintaining their relative order in the sorted outs. Here is algorithm, and the input is an array A from 0 to n minus 1 of n elements. Output is an array A from 0 to n minus 1 sorted in increasing and non-decreasing order. For I will be equal to 1 to n minus 1, do V will be equal to A of I, J will be equal to I minus 1. Why J will is greater than or equal to 0 and A of J is greater than or equal greater than V, do A of J plus 1 is equal to A of J, J will be equal to J minus 1 and A of J plus 1 will be equal to V. Here are the steps to perform insertion sort. Start with the first element as a sorted region. Take the next element from the unsorted region and, and compare. Take the next element from the unsorted region and compare it with the elements in the sorted region. Insert the element in the sorted region at a correct position. Repeat the process until the unsorted region is empty. The sorted region now contains the entire input list. Well, here is the example of how insertion sort works. Suppose we have the following input list. Suppose we have the following input list like 89, 45, 68, 90, 29, 34, 17. First iteration for I will be equal to 1 to 6, V will be 45 and J will be 0, while 0 is greater than or equal to 0 and 89 is greater than 45, it's a true, while minus 1 is greater than or equal to 0, it's a false. So array of a 0th element means A of 0 will be equal to 45. In the array list, 45 and 89 will be separated from the list. In the second iteration, I will be equal to 2 to 6, V will be equal to 68, J will be equal to 1, while 1 will be greater than or equal to 0, and 89 is greater than 68, it's a true statement, while 0 is greater than or equal to 0, and 45 is greater than 68, it's a false statement. So a array of 1 will be equal to 68, and here 45, 68, and 89 will be separated from the list. In the third iteration also, same procedure will be followed, where a 45, 68, 89, 90 will be separated from the list. In the fourth iteration of I will be equal to 4 to 6 and V will be equal to 29, J is 3. In this 29, 45, 68, 89, 90 will be separated from the list. In the fifth iteration, except 17, every number will be separated. And finally, in the last sixth iteration, the all the array elements will be separated. And finally, the sorted array in this array list is 17, 29, 34, 45, 68, 89, and 90. It will be in the ascending order. Insertion sort efficiency. Insertion sort is a simple sorting algorithm that builds the final sorted array one item at a time. Its efficiency is based on its ability to efficiently sort small arrays or partially sorted arrays. Insertion sort has time complexity of omega of n power 2 in the worst case scenario. Best case scenario for insertion sort is best case complexity for the insertion sort is omega of n, where the array is already sorted. In this scenario, the algorithm only compares each element with its adjacent elements and moves on to the next element. This makes insertion sort highly efficient daily when dealing with nearly sorted. Here is a summary of the insertion sort. Insertion sort is a simple and efficient algorithm for small data sets or partially sorted arrays. While it may not be the most efficient for large data sets, it has its advantages in specific scenarios. Understanding the efficiency and limitations of the insertion sort can help in choosing the right sorting algorithm for different tasks. We're gonna start with the topological sorting introduction. A topological sorting is a method used to order the vertices of the directed acyclic graph or a DAG in a linear order. It ensures that for every directed edge from vertex U to vertex V, U comes before V in the ordering. This ordering is useful to scheduling tasks and resolving dependencies and optimizing operations. Understanding directed acyclic graph DAGs. A directed and acyclic graph is a graph with a directed edges and no cycles. In a DAG, nodes are arranged in a way that there is a consistency directed of the direction of the dependencies between nodes. Topological sorting is only applicable to DAGs as it requires linear ordering of the nodes without any cycles. Depth first search DFS algorithm overview. Depth first search DFS is a recursive algorithm that explores as far as possible along each branch before backtracking. It uses a stack to keep track of nodes to visit and marks each visited node to avoid revisiting them. DFS is commonly used in graph traversal, topological sorting, and finding connected components in a graph. Here is an example of that where selected is a table where selected vertex, adjacent vertex, and the pop vertex columns are. In selected vertex, we go from A. A A is a selected vertex and its adjacent vertex is B, and pop will be no vertex. Pop vertex will be no null. And from B to E, B's adjacent vertex is E, and is a no pop. And from no incoming for a no outgoing elements from E or arrows from E. So E will be popped and again it will return to the previous thing, the B. From B to G it will go, and from G to F, and F will be popped out cause no outgoing arrows or outgoing letters are there. And G, from F2 it will go for again G reverse the previous one G. G will be pop and again to B, B will be pop and again it will go for A, and from A to C it will go, and again it will go for C, and from C other than F no other letters are there, so C will be popped and it will again go to A will be popped, and finally that D will be remaining and it will be also pop. C, and the topology is called sorting order is D A C B G F E. Source removal methods for topological sorting. In these source removal methods, we repeatedly remove nodes with no incoming edges from the graph. That remove the nodes from the topological order of the graph. This method is sufficient for topologically sorting. A DHs can be implemented in a linear time complexity. Here is example of the of a screen which had been seen in the last step. Step 1, remove D and see the first line. Topological order is first is D. Step 2, remove A and the graph. Topological order is DA, and third step 3 is remove B. Topological order is DA and B. Step 4 is remove C. Topological order is DABC. Step 4 is remove G. Topological order is DABCG. Step 6, remove E. Topological order is DABCGE. And here is final topological order like DABCGEF. Well, thank you.